So this is slide 22, the warm-up. It says use your factoring flowchart to help you if you've forgotten how to factor each of these. So it's going to be important to be able to factor today. To factor number one, right, using your factoring flowchart, first we look for a greatest common factor. Between 16 and 625, it doesn't look like there are any greater common factors other than 1. So we go on and look at it as a binomial. It is the difference of two perfect squares, so we're going to start factoring that. So using the difference of perfect squares pattern, we would have 4g squared minus 25 times 4g squared plus 25. And then just make sure you factored completely. The first factor is also a difference of perfect squares, so we want to continue to factor that. This is only the sum of squares, so this one is prime, but we factor the first factor. So that would be 2g plus 5, 2g minus 5, and then we bring over the prime factor for g squared plus 25. For the second one, we'll look for a GCF, t for sure, to the second power. Also 4 goes into each of the coefficients. So we can factor out a 4t to the second power, and we would be left with t to the fourth power minus 5t to the second power plus 6. From there, we can see if we can factor this as a general trinomial. Even though the degrees are higher, we can still look for factors of this number, right, that add up to this number, and luckily there are. So this is prime, so we're going to leave this guy alone, but we can still factor this trinomial as a general trinomial. So we'll keep the GCF in front, factor out the factors of t to the fourth power would be t to the second and t to the second. Factors of 6 that add to negative 5 would be a negative 6 and a positive 1. Neither of these are the difference of two squares, so you can't factor any further, so that is factored completely. Number 3, this one is only two terms, right? The GCF is 1. It is not the difference of squares, so we check for it being the difference of cubes, which it is. So remember, difference of cubes is going to be 2 terms and 3 terms. So the cube root of 27, right, is going to be 3. The cube root of y to the third power would be y. And what goes in between them is a minus sign. In the next set of parentheses, remember the first term is going to be this number squared. So that's 9. The middle number is going to be the product of these two numbers. So that would be 3y. And then the last term is going to be this term squared. So we have y squared. So just be careful of your signs. In this case, you want to make sure that you remember the pattern. And that pattern is minus, plus, plus. Taking a look at this, nothing to factor out any further. For this trinomial can't be factored any further, so that's going to be our final answer. And then lastly, with this 4-termed polynomial, all 4 terms, their GCF is 1, so we're going to try to factor by grouping. The first 2 terms have a GCF of 7x squared. If we factor that out, we'll be left with 4x minus 1. GCF of the next 2 terms is going to be 9, a positive 9. If we factor that out, we'll be left with 4x minus 1. We see that repeated factor, so we can factor that out as the new GCF, and we're left with 4x minus 1 times the quantity of 7x squared plus 9. Neither of these are factorable any further, so that's our final answer. For the last one, for number 5, it says to find all real solutions. So in this case, we're not going to be able to get x by itself unless we solve by factoring, because we have multiple degrees. So if we do that, we want to put the orders, we want to make sure that this is in standard form. So we're going to subtract 2x from both sides. And then write it set equal to 0. And then I'm going to write it in order from highest to lowest degree, x to the third power plus x squared minus 2x. There's a GCF of x, so we're left with x squared plus x minus 2. That is a general trinomial. So we're looking for factors of -2 that add up to a positive 1x, right? So we have x here, x there. Factors of -2 that would add up to a positive 1. Well, that's going to be a positive 2 and a -1. And since we're finding all real solutions, now we can use the zero product property. So we have 1 solution, 2 solutions, 3 solutions. Then that brings us on to slide 23. It says today we'll be dividing polynomials. So we haven't done this before where we take 4 terms, right? Remember to think that these operations are all like glue. They glue everything together, so we have this entire polynomial that's divided by this entire polynomial. We haven't seen this yet before. So let's move on. On slide 24, this is just a little bit of vocabulary. It says dividing polynomials. So if you take f of x and you divide it by d of x, that's going to give you the quotient. And sometimes you have a remainder left over, which still needs to be divided by d of x, which was your original divisor. We can see this very quickly if you did something like 10 divided by 3, right? 3 goes into 10 3 times, so that would give us 9 underneath. 10 minus 9 is 1. There's 1 remainder. So it's the answer for 10 divided by 3 is 3, and 1 remainder still needs to be divided by 3, so it's 3 1/3. I'm going to zoom in a little bit. So it says, remember when we factored polynomials, we were breaking them down into their prime factors, which is similar to dividing. Remember when something is divided evenly, the remainder is always, right? If this was evenly divisible, then our remainder would have been 0, which it wasn't. Let's see if x minus 2 is a factor of f of x by dividing using polynomial long division. So I'm going to show you what polynomial long division is. This one is the less favorable way of dividing. We're also going to use synthetic division today. So I'm going to write this just like I did the previous division problem, with x minus 2 as my divisor, and my other polynomial as what's called the dividend. So we have x to the third power plus 5, make sure that looks like a 5, x squared minus 7x plus 2. To divide this, we're going to divide it similar to dividing a 2-digit number. We're first only going to look at x right there. So we're going to divide this first term by this first term. X to the third power divided by x is x squared. So off to the side, I'm going to write that. X to the third divided by x is equal to x squared. That answer is going to go right up here, just like we did over here, right? When we divided 10 by 3, we got 3. But there is going to be a remainder situation in this particular part because we're not just dividing by x, we're dividing by all of this. So in order to do that, what we're going to do is take x squared, multiply it by all of this. So we have x squared, multiply that by x minus 2. That's going to be x cubed minus 2x squared. We need to subtract this from these two terms. So we need to subtract, and I'm going to use parentheses, x cubed minus 2x squared. Draw my line, and then just subtract. So these will cancel out. 5x squared minus a negative 2x squared, right? That's going to turn this into a positive 2x squared, so that will be 7x squared. Then we bring things down, so that's why this is called long division, because it's the long way of doing it. And then we're going to repeat the process. Okay, so now we're going to take 7x squared and divide it by just the x. So off to the side, I'm going to write that 7x squared divided by x. That gives us 7x. That number is going to go up here, right? The positive 7x, so that's going to go up there. For then, we take 7x, and we're again going to multiply not by just the x, but all of x minus 2. So I'm going to show that over here again. So we'll get 7x squared minus 14x. This is what I need to subtract now from these two terms. So I'm going to subtract 7x squared minus 14x. But that needs to go in parentheses, right? These will cancel out. Minus a negative makes this a positive 14x. So we have negative 7x and a positive 14x, so that's going to give us 7x. Then finally bring down this 2, and we just have one more division to do before we get our answer. So now 7x is divided by just the x. So 7x, I guess I can write that over here now. 7x divided by x, that's just going to be 7. That goes here. We know that our job's almost finished because we are running out of space to put our quotient. And then we're going to do what we did previously. We're going to multiply this number by both of these terms. So again, we're going to now take 7, multiply that by x minus 2. So we'll get 7x minus 14. When I do that, I'll subtract 7x minus 14. These cancel out. Again, this is 2 minus a negative, so this is really positive 14 plus a 6, that gives me 16. That's my remainder, right? So my remainder, just like I did with this one remainder up here, still needs to be divided by the divisor. So my remainder is 16, so I need to divide that by the divisor, which is x minus 2. So it says, let's see if x minus 2 is a factor, right? We just determined it's not, right? This is not a factor. So we can say x minus 2 is not a factor of f of x because there is a remainder of 16. If you need to rewatch that video on dividing polynomials, I would recommend it just so that you understand fully how to do long division. It's important to know how to do. But now we're going to move on and we're going to talk about synthetic division. So to do that, we're first going to take a look at the first bullet, which says to use synthetic substitution, right? We learned synthetic substitution before to evaluate f of x when x is equal to. So that means we're trying to find f of 2. So remember with synthetic substitution, right, the 2 would go here, and then the numbers that we get on the inside of our chart is going to come from our function, right? Our function is this f of x right here. So all of these guys. We're going to use just the coefficients, remember? So the coefficients from that particular function, right, start off with 1 with a third degree, 5 with a second degree, -7 with the first degree, and 2 with a degree of 0. So there's no need to put a 0 anywhere here as a placeholder. We'll drop down the 1. 2 times 1 is 2. 5 plus 2 is 7. 2 times 7 is 14. -7 plus 14 is going to be 7. 2 times 7 is 14. 2 plus 14 is 16. So you'll notice there's my remainder, right? So what happens now is we can use synthetic substitution to figure out what the remainder is going to be. And you'll also notice that these numbers are really familiar. Hopefully you recognize that with some of the operations, right? These numbers match up with the numbers from our quotient up here, right? 1, 7, 7. Here we see 1, 7, 7. So like I said before, these numbers are going to be important when doing division. We'll talk about that in just a bit. But this is right now just trying to establish that we know that when we use synthetic substitution to determine this value, it's going to tell you the remainder when f of x is divided by this binomial. It says, notice the other numbers below the line. These match the coefficients of the quotient. So that's what I was talking to you before, right? The 1, 7, 7, they matched up with the x squared plus 7x plus 7, right? So that was very important. Now, this is the only disclaimer. This method can only be used to divide a polynomial by a divisor of this form right here, x minus k. So that's very important to remember. On to our last slide for today. This is slide 26. The remainder theorem. It states if a polynomial f of x is divided by anything that looks like x minus k, then the remainder r is f of k, right? Which is what we just showed in the last video, in the last slide. So it says use the remainder theorem to determine the remainder when f of x is divided by x plus 3. Use synthetic division to divide f of x by x plus 3. So the first thing we're going to do is use the remainder theorem to determine the remainder. So we're going to do that first. First, it's important if we're trying to use synthetic division, we're going to have to know what the k value is, right? So the k value is this guy. So if the general form is x minus k, and here I have x plus 3, right? I need to rewrite this in terms of x minus something. X plus 3 is the same thing as x minus a negative 3, right? So that actually means that our k value is going to be negative 3. So to use synthetic substitution, we're going to need to find f of negative 3. If we find f of negative 3, that's going to tell us the remainder. So let's do that over here off to the right side. Move the paper a little bit so it's a little bit more centered. So here we'll have our chart. Negative 3 is our k value, so you would see how this would be very different if I accidentally used 3 as my k value. So be careful. So negative 3 is the value. I want to make sure that I'm using the coefficients from what I'm dividing, right? So this is 1, this is 4, this is negative 1, this is negative 1. I'm not missing any degrees, right? 3, 2, 1, 0, so I don't need any placeholders. So I have 1, 4, negative 1, negative 1 again. So let's find the remainder. We're going to drop down the 1. Negative 3 times 1 is negative 3. 4 plus a negative 3 is going to be positive 1. Negative 3 times 1 is negative 3. Negative 1 and negative 3 is negative 4. Negative 3 and negative 4 multiply to a positive 12. Negative 1 plus 12 is going to be 11. So it says we're going to use, so this is what we can do to find the remainder. So the remainder is definitely going to be 11, right? So 11 is the remainder. Use synthetic division to divide. So synthetic division, so we're actually not going to use long division to actually divide this. We're going to use what we just learned from the previous slide. So this is our remainder. These numbers are part of the quotient, right? The answer. So if we're dividing f of x by x plus 3, right? It's going to equal, we're just going to put these numbers in there. So for right now, we're going to write 1, 1, negative 4, and 11. Now, each of those terms needs a variable with a degree. So we always start here, knowing that this is going to be the remainder. Your remainder always needs to be divided by your divisor. So 11 divided by x plus 3. This is positive, so it's going to be a plus. From here, we go to negative 4. This is always going to be a constant. So we're going to leave that with no variable. Then we're going to add a degree to a variable as we move to the left. So this will be x to the first power. We'll just leave it as 1x. Then we'll go up by a degree on this next term. So we need to write this as 1x squared. And there's our answer. This is the answer to the division, right? It doesn't go in evenly, so there's a remainder, so it still needs to be divided by x plus 3. We got these coefficients from these numbers in the synthetic substitution process that we're used to, but now that we're using it to divide, we're calling this synthetic division. Okay? And how we determined whether or not they would have variables or not, right? We'd start with this, the first number, right? We always know that's always the remainder. The next number after that is always going to be your constant, so that has a degree of 0. Then it goes up by degree. This has an x to the first degree, and this has an x to the second degree. You'll notice this should be positive 1, so I forgot my plus sign there. All right, and that is how we divide polynomials. So on to the next slide. That shows you what your homework is. I've selected 1, 2, 3, 4, 5, 6, 7 problems. The 7th problem, number 19, just says to describe and correct, so make sure that you do that. There is help if you need it. Here's practice with polynomial long division, right? If the directions say to use long division, make sure you do that. Your formative will be next week on February 4th. Okay, so this link, right, is on our slides in Canvas on slide 27. All right, and then stay tuned for tomorrow's video.